Need to lock down your FastMCP server with GitHub Authentication, but don't want to wrestle with OAuth complexity? You'll see exactly how to configure GitHub as your auth provider in just a few lines, then create a protected tool that automatically extracts user details from GitHub's OAuth tokens. The pattern handles everything from token validation to user data access, with zero manual session management. From FastMCP, import FastMCP. From FastMCP server, auth providers, GitHub import GitHubProvider. Hash the GitHubProvider handles GitHub's token format and validation. Auth provider equals GitHubProvider. Client ID equals auth23 ly abc def guy jk lmn. Hash your GitHub OAuth app client ID. Client secret equals GitHub pat. Hash your GitHub OAuth app client secret. Base URL equals http://localhost 8000. Hash must match your OAuth app configuration. Hash redirect path equals /auth/callback. Hash default value. Customize if needed. MCP equals FastMCP. Name equals GitHub secured app. Auth equals auth provider. Hash add a protected tool to test authentication. At MCP tool. Async def get user info. Dict. Returns information about the authenticated GitHub user. From FastMCP server dependencies, import getAccess token. Token equals getAccess token. Hash the GitHub provider stores user data in token claims. Return. GitHub user, token claims get login. Name, token claims get name. Email, token claims get email. This demonstrates the OAuth proxy pattern for integrating traditional OAuth providers with modern RPC frameworks. The pattern bridges systems that don't natively support dynamic client registration by handling the OAuth flow externally, then injecting the resulting credentials into the framework's native authentication system. What makes this distinctive is its ability to maintain framework-agnostic security while supporting providers like GitHub that require pre-registered clients. The approach works by externalizing the authentication flow while keeping the application logic clean. The GitHub provider handles the OAuth dance, token validation, and user data mapping, then presents the framework with a standardized token containing claims. This separation means your tools remain unaware of the authentication mechanism, working purely with the resulting identity claims through a consistent interface. This pattern matters because it solves the common problem of integrating legacy OAuth systems with modern architectures without compromising security or developer experience. It's particularly valuable when you need to secure RPC endpoints with existing identity providers, but want to avoid embedding provider-specific logic throughout your codebase. The trade-off is slightly more complex initial setup, but the result is cleaner code and more flexible authentication options. Let's break it down. From FastMCP, import FastMCP. From FastMCP server, auth providers, GitHub import GitHubProvider. Imports FastMCP, the core framework for building AI-callable tools, and GitHubProvider, a pre-built authentication handler for GitHub OAuth. This establishes the foundation for secure tool exposure, where FastMCP manages the tool interface while GitHubProvider handles token validation and user identity. The pattern separates auth logic from business logic, keeping your tool definitions clean. Auth provider equals GitHub provider. Client ID equals auth23 ly abc def guy jk lmn. Hash your GitHub OAuth app client ID. This initializes GitHub OAuth authentication using your app's client ID. The client ID identifies your application to GitHub's OAuth system, enabling the token exchange flow that verifies user identity. Without this, the auth provider can't request or validate GitHub tokens.
MCP equals FastMCP. Name equals GitHub Secured App. Auth equals auth provider.
This initializes the FastMCP server instance with GitHub Authentication. The auth parameter wires up the GitHub provider we configured earlier, enforcing that all tool calls require valid GitHub OAuth tokens. Without this, the tools would be publicly accessible with no authentication.
Hash add a protected tool to test authentication. At MCP tool. Async def get user info, dict, returns information about the authenticated GitHub user.
This defines an AI callable tool that requires authentication. The @MCP tool decorator exposes this function to AI models, while FastMCP's auth layer automatically enforces GitHub OAuth protection, and the type hint plus docstring become the tool's schema.
From FastMCP server dependencies, import GetAccessToken.
This imports GetAccessToken, a dependency injector that retrieves the validated OAuth token from the current request context. It's the standard way to access authenticated user data in FastMCP tools, eliminating manual token handling.
Token equals GetAccessToken. Return.
This retrieves the authenticated user's access token from the current request context. The token contains GitHub's validated user claims, enabling secure access to user-specific data without additional API calls. GitHub OAuth integration pattern. The GitHub provider abstracts GitHub's opaque token validation by handling the OAuth flow and user data extraction automatically, while the @MCP tool decorator exposes protected endpoints to authenticated clients. The base URL must exactly match your GitHub OAuth app configuration or authentication will silently fail. This pattern turns GitHub credentials into a transparent authentication layer for your FastMCP tools.
The provider that knows nothing of your users knows everything about them.